Hi friends, welcome to S.A.ENG.COLLEGE GATE Coaching Class. I am N.MAGADEVI, Associate Professor, Department of EEE. Today we are going to discuss about the topic complex power and power factor in AC circuits. Why we are taking the AC circuits, why it is important, why we are not taking the DC circuit means AC circuit is having the complex power and power factor. Because in case of AC only, we are having the various passive components like resistor, inductor and capacitor and all. If you are taking the resistor means the voltage and current will be in phase. We know very well what is meant by voltage and what is meant by current. So they will be in phase in case of resistors. But in case of the passive elements, inductor and capacitor, it will be out of phase. So what is meant by out of phase? Why it is out of phase in inductor and capacitor? Because in case of resistor, it will dissipate the energy in the form of heat. But we are taking the inductor and capacitor, it will store the energy in the form of electric field and magnetic field. So your current may be lagging or leading in nature in case of resistors and inductors. So that only we are taking about the power and power factor. That is not the power, it is a complex power and power factor in AC circuits. It is very, very important role in AC circuits because in most of your supply will consist of AC only. So most of the components will use the AC supply. So the power and power factor plays vital role in AC circuits. Okay, what is meant by power? Power is nothing but the rate of doing work. And what is meant by power factor? It is nothing but how the power is utilized effectively. It is given by the power factor. So this is a GATE syllabus and this is the topic we are going to discuss. And what is the various elements in the complex power means real power, reactive power and apparent power. And let us see one by one. So what is a real power? It is nothing but the power consumed by a resistive load. So if you are taking a load means it may be a R load, L load, C load or otherwise a combination of this RL load, RC load and then RLC load. In sometimes we will use the LC circuit also. So but in case of real power, it is a power consumed only by the resistive load. And the next one is reactive power. So reactive means it will react. So it will react, it may consumed by the inductive load or it may be supplied by the capacitive load. And what is the apparent power? It is nothing but the combination of real power and reactive power. Okay. Next, we will discuss about the AC circuit. So AC is nothing but alternating current. So usually we will use the direct current and alternating current. Here we are discuss about the alternating currents. So the complex power plays a vital role in the AC circuits. In AC circuits, there are various important parameters are there because in case of DC means we will use only plus or minus 5 volt means it will take plus 5 volt on horizontal line like that or otherwise minus 5 volt like that only. But in case of alternating current means actually in AC generator, that is in alternators, it will generate only the alternating currents. So what is meant by alternating? It will alternate between the positive and negative cycles. And the next important thing is which wave it will take. It will take the sine waveform. It will take the positive off cycle or it may be in the negative off cycle. So the combination of one positive off cycle and one negative off cycle constitute a complete cycle. So in case of DC it will follow a horizontal line, but in case of AC it will take a sine waveform. So the voltage waveform will be a sine waveform and current waveform will also be a sine waveform. Next important thing is what is the expression for voltage and current? If you are taking the voltage waveform, already we told that it will take a sine waveform. So in case of sine theta, if we are substituting theta is equal to 0 means sine 0 0, so it will alternate from 0. And at the same time, if you are substituting theta is equal to 90 degree, it will take the positive peak. Similarly, if you are substituting means we will get a sine waveform. So your voltage waveform will be a sine waveform. In case of AC generator or alternator, the induced EMF will be purely alternating current only. After that only, we will convert into direct current by means of commutator and all. Similarly, if you are using a resistive load means your current will be according to Ohm's law, I is equal to V by Z. In this case, it is V by R. I is equal to V by R for a pure resistive load. So it will also follow the sine waveform because the numerator is voltage. It is Vm sin omega t means current will also be Im sin omega t, but the magnitude will be little bit lesser because of the resistor. Because resistor is nothing but it will oppose the flow of current. It will dissipate the energy in the form of heat. So the magnitude will be lesser, but it will also follow the sine waveform. So your current waveform equation is I is equal to Im sin omega t. And here it is plus or minus theta. Why we are putting plus or minus theta means this is for the inductive and capacitive load. It may be lagging or it may be leading. Because in case of inductor, it will lag the voltage. In case of capacitor, it will lead the voltage. So that only we are putting plus or minus theta. What is the angle theta? It is nothing but the phase angle. What is phase angle? Phase angle is nothing but the angle between the voltage and current. This is a phase angle. So that only we are taking V is equal to Vm sin omega t for the voltage equation. I is equal to Im sin of omega t plus or minus theta, where theta is the phase angle. Next thing is power factor. What is power factor? Cosine of the phase angle is nothing but the power factor, that is cos phi. And the next one is in phase and out of phase. So already we told that in case of a resistive load, your voltage waveform and the current waveform will be in phase. That is, whenever your voltage starts, your current waveform will also starts. Whenever the voltage waveform reaches the maximum peak value Vm, at the same instant your current will also reach the peak value. Whenever your voltage reaches 0, your current waveform will also reaches the 0 value, this point. And whenever your voltage reaches the negative peak, your current will also reaches the negative peak. Similarly, it will goes on. So that it is called as in phase. This is possible in case of only a pure resistive load. But in real-time applications, it may consist of a RL load or RC load or RLC load only. So it won't follow the in phase. It will follow the out of phase. So what is out of phase? Your voltage waveform and the current waveform will not be in phase. For example, this is for the lagging circuit, that is for a inductive load. So in this inductive load, your voltage waveform starts from 0, but the current waveform starts after the angle phi. Here the phi angle is 30 degrees. So your phase angle is 30 degree. And what is the power factor? You have to take the cos 30. That's all. So after 30 degree only it will reach. For example, if the voltage reaches the positive peak by pi by 2, exactly pi by 2, your current waveform will reach the Im after that only, that is pi by 2 plus 30 degree. Similarly, it will goes like that. That is, your current waveform lags the voltage. This is for the inductive load. This is called as out of phase. Out of phase means it may be for inductive load or it is meant for the capacitive load. In case of inductive load, we are taking the current waveform here. In case of capacitive load, we have to start it from here. That is before the voltage waveform, we have to take the current waveform. And the next thing, the next important parameters are impedance. So what is impedance? In case of DC circuits, we will tell it as resistance. That is, it will opposes the flow of current. But in case of impedance, that is in case of AC circuits, we will tell like that. That is impedance. That is impedance or nothing but it will opposes the flow of current. This is for the AC circuit only. Okay. So that impedance is represented by the letter Z and the unit is same as resistive only, ohms. And what is the RLC circuits? In case of RLC circuits, what is the Z equivalent value means? It consists of, in case of RLC circuit, there will be a resistor, there will be inductor, there will be a capacitor. And these are connected in series means it is called as RLC series circuit. Now in this case, what is the Z equivalent means? You have to find resistance of a resistor and the reactance of a reactive, that is inductive reactance XL and the capacitive reactance XC. We have to add all the impedances. Then only it will give the Z equivalent value. That is total impedance of the circuit. So the Z is equal to R plus or minus JX. Why we are putting J for the reactance? Why we are putting the J for the reactance? Because in case of voltage, in case of inductor or in case of capacitor, J plays a vital role. Why we are introduced the J operator means whenever there is a phase shift, whenever there is a, if you want to multiply a vector by j operator means the resultant vector will be rotated by an angle of 90 degree. For example, if your vector is along this direction, that is, for example, you can take it as E vector. If you are multiplying it by j operator, E into j will be rotated by an angle of 90 degree in the counterclockwise direction. Okay, so that only we are putting the j operator here because they are not in phase, they are out of phase. So we have to give the phase angle between these two. So that only we are introducing the j operator. And for a pure resistor, your Z equivalent value will be R, and for a pure inductor, its value will be XL. Now what is XL? L is nothing but a inductor, C is nothing but a capacitor. What is that XL and XC? L is the inductance value, C is the capacitance value. What is XL and XC then? XL is nothing but inductor reactance, XC is nothing but capacitive reactance. That is, inductance value, its unities will be in, what is inductance? Flux linkage per unit current is nothing but the inductance. The unit of inductance will be in henries. What is capacitance? Capacitance is nothing but C is equal to Q by V. Its unities will be in farad. But in case of, if you are adding it here, we cannot able to put it as L, C like that. In this case, what we have to substitute? We have to substitute all the units belongs to ohms only. So how to convert the XL and how to convert the inductance to Henry and the capacitance value is in farad means we have to combine. That is, how to combine this? We have to take the reactance value. So inductive reactance is XL, capacitive reactance is XC. So XL is nothing but 2 pi FL, XC is nothing but 1 by 2 pi FC. So in that way we can convert the henries and farads in terms of ohms. Then only we can add with the resistance value because resistance value is already in ohms. So we have to substitute the XL and the XC value in terms of ohms. So that only we are putting the X here. And why we are putting plus or minus? Plus is for your inductor, minus is for the capacitor. Because in case of inductor, current lags the voltage. In case of capacitor, current leads the voltage. So if it is lagging means, what is the degree we have to put? We have to put 270 degrees because this is a reference vector. It is rotated by an angle of 270 degrees. So it is plus jXL, or others you have to put the plus jXC for a pure inductor and pure capacitor. Okay, and XL value is 2 pi FL, and that 2 pi F can be replaced by omega. So we can put j omega L also. And similarly for in case of EXC, we have to put 1 by jXC, j omega C. We can put like that, and we can add it. And we can find out the Z equivalent for a RLC series circuit. For example, if you are taking a RL circuit, so it consists of only resistor and inductor means the resistance value is R and the inductive reactance value is XL. So what we have to put? R plus JXL, because in case of inductor, R plus JX, in case of capacitor, R minus JX. So it is R plus JXL. If you want to find out the magnitude, so how to find out the magnitude? We have to put the square root of the real part plus imaginary part, square of R square plus XL square. So square root of R square plus XL square. So this is the equivalent value for a RL circuit. And the next important thing is impedance triangle. So what is a impedance triangle? Because resistance and the resistance value and the inductive reactance value are not in same phase. They are out of phase. They are multiplied by the j operator. So if you are drawing the vector diagram, you have to take the resistance along the x-axis and the inductive reactance, it will rotate by an angle because we are multiplying it by the j operator. So it is rotated by an angle of 90 degree. That is jXL. That is R plus jXL. It is not necessary to put the j here because already the vector is rotated by 90 degree in the counterclockwise direction. So it is not necessary to put the j operator here. So R plus jXL. If you are adding it vectorially, how to add it vectorially? There are two types of vector addition. Triangular law of addition and parallelogram law of addition. What is a triangular law of addition? If one vector is originated and terminated at one point, second vector is originating from the termination of the first vector, means you have to use the triangular law of addition. What is a parallelogram law of addition? If both the vectors are originated at the same point, we have to use the parallelogram law of addition. It is nothing but we have to draw a parallelogram and the diagonal is given by the resultant vector. Here, this is R vector, it is terminating here. JXL vector is originating from here. So it is enough to use the triangular law of addition. That is, we have to join the origination of the first vector, termination of the second vector. It is nothing but your Z. And we have to denote the angle phi. Whenever there is inclination, we have to give the angle. That is, we have to give the phi here. At the same time, it is a pure inductor, means we have to put the 90 degree here. So if Z is equal to, by seeing the triangle, we can say it is R plus JXL. So this is a Z equivalent value. And what about the power factor for this circuit? Power factor is given by the cosine of the angle between the voltage and current. The angle between the voltage and current is phase angle. We have to find out the cosine of the phase angle, that is cos phi. So what is the cos phi value from this triangle? Adjacent by hypotenuse, that is R by Z. So this is the power factor of the RL circuit. And the next one is power in AC circuits. So actually our topic is complex power and power factor. Now only we are entering into the power in AC circuits. So what is the power? What are the various powers in AC circuits? Means first one is instantaneous power. So what is the instantaneous power? If you are seeing this current, see this current waveform. In the current waveform, along the x-axis we are taking the time, along the y-axis we are taking the current. At each and every instant of time, we are denoting the current value. At the instant t1, current is I1. At the instant t2, current is I2. So like that, its value is varying at various instants. So that only it is called instantaneous value of the current. Similarly, we can draw the waveform for the voltage, because power is nothing but Vi cos phi. So this is your current waveform. Similarly, we have to draw the voltage waveform. Same principle. We have to draw the voltage waveform. Magnitude will be somewhat higher when compared to this one. Next thing, we have to multiply the voltage and current. And then we have to multiply by the power factor. Then only we will get the instantaneous power. So the instantaneous power is given by Vm Im divided by 2. So what is the Vm and Im? Vm is nothing but the maximum value of the voltage. Im is the I max value. And the cos of the 2 omega t plus phi plus cos phi. Well, how it is coming here means V is equal to Vm cos omega t, I is equal to Im sin of omega t plus phi. We are taking like that. So that only it is coming like that. We have to apply the cos A cos B formula. Cos of A plus B by 2 plus cos of A minus B by 2. So after substituting, we will get the instantaneous power as this one. And the next power is average power. So what is the average power? It is nothing but just we have to take the average. That is, we have to integrate. So integrating is nothing but combining all the instantaneous value and divided by the time period. That is, we have to add all this and divided by the time period. So we will be getting like this. In this case, we are taking V is equal to Vm sin of omega t plus theta. I is equal to Im sin of omega t plus phi. And the next one is complex power. This is our topic. So what is a complex power? So already in maths, what is a complex number? We know that it consists of real part and imaginary part. Here also we are having the real part and imaginary parts. So that only it is called as complex power. So in this, real part is the real power P and the imaginary part is the reactive power Q. So we can represent the complex power as S is equal to P plus JQ. So this is a one form. Another form of representation is we can represent the complex power S is equal to V into I conjugate. So what is the I conjugate? I is nothing but the current flowing through the load, and if you are taking the conjugate, for example, if you are having a number 3 plus 4j means that is a complex number. It consists of real part and imaginary part. What is the complex conjugate of the number? 3 minus 4j. Like that, you have to take the complex conjugate of the current flowing through the load. So your complex power is V into I conjugate. And the next step, what are the various formulae we are going to use it in the complex power for the inductive load, for the capacitive load, and the combination of the RL loads or RLC loads. So how to find out for a inductive load? So first, if you are taking for inductive load, it is S is equal to P plus JQ. Here the Z is given by R plus JXL, already we know that. And what is the power factor? R by Z, already we know that. But the important thing is the power factor is lagging in nature because the current lags the voltage. And the inductive load will give the lagging VAR. So what is VAR? Voltage, ampere, reactive. So that is what VAR. So it will decrease the overall power factor of the circuit, power system. It will reduce the power. Your inductive load is maximum means it will reduce the power factor of the overall system. And the next one is complex power in capacitive loads. So in case of capacitive load, what is the impedance value? R minus JXC. Already we know that Z is nothing but the impedance. It is equal to R plus or minus JX. That X may be XL or XC. XL means inductive reactance, XC means capacitive reactance. Inductive reactance means plus, capacitive reactance means minus. So already we have completed this. So your S is equal to P minus JQ. And what is the power factor? Here also the power factor is R by Z only, the same formula only, but the difference is in case of inductive load, lagging power factor. In case of capacitive load, it is a leading power factor. And also the capacitive load will provide the leading VAR, that is voltage amps are reactive. That is, it will improve the overall power factor. So the overall performance of the power system will be improved if you are adding the capacitor in the circuits. So this is a very important thing, so that only we will use at the receiving end, we will use the capacitor banks. It will improve the power factor and it will improve the overall performance of the power system. Complex power triangle, that is a power triangle. So what is a power triangle? So already we know that your S will consist of the real part and also imaginary part. So the real part is nothing but your VA cos phi, imaginary part is nothing but your VA sin phi. So why the VA cos phi? Why we are multiplying cos phi here? Why we are multiplying the sin phi here means voltage waveform will be like this and the current waveform will be lagging. If you are projecting along your voltage waveform, that phase angle is cos phi, that is the adjacent side. So if you are multiplying voltage with your current, it is not a total current, it is I cos phi, because we are projecting along this axis. So it is I cos phi. So the voltage value is V only, but the current value is I cos phi. So if you are multiplying the voltage and the current, it is not only VA, it is VA cos phi. This is for our real power. And the next one is reactive power. Reactive power means already we know that it will be in the 90-degree opposite. So what we have to do? We have to take it on the opposite side, projection. We have to change the projection. So horizontal projection is I cos phi, vertical projection is I sin phi. So automatically we will get the I sin phi here and the resultant vector will be rotated by an angle of 90-degree. So this is our VA cos phi real power and this is our VA sin phi reactive power. And the next thing is what are the units? Because we are telling all our power. How to differentiate the various power means real power, the unit is in kilowatts because it will dissipate the energy in the form of heat energy. So it is kilowatts. But in case of reactive power, it will react. So the unit is in VAR. And the next one is apparent power. So we have to add it vectorially. Real power and then reactive power, we have to add it vectorially. That is where to use the triangular law of addition. So if you are adding like this is nothing but your apparent power. So this is real power, reactive power. We have to add it vectorially. This is nothing but our apparent power. That is the hypotenuse of this triangle. This is nothing but your apparent power. And now what is the unit of apparent power? It is kVA. Okay, it is kVA. And what is the power factor using this triangle? This angle of inclination is phi. Now using this triangle, what is the power factor? Power factor is nothing but cos phi. Cos phi is adjacent. That is adjacent power divided by the hypotenuse. So adjacent power is real power or active power divided by hypotenuse is nothing but our apparent power. So VA cos phi divided by VI, you will get the cos phi, that is our power factor. And this is the 4-quadrant operation of the powers, various powers. So what is this? See the first quadrant, it is an inductor. Third quadrant, it is also an inductor. But in this case, the inductor is energizing. But in this case, the inductor is de-energizing. Similarly, the capacitor. So in this case, second quadrant, the capacitor is charging. Here it is discharging. Okay. So these are the various quadrant operation of the capacitor and inductive circuits. Let us see the problem on the power factor. This is a gate question 2012. So in the circuit shown below, this is the circuit they are given. So whenever they are putting this sine waveform, it is nothing but a AC source, and whenever you are seeing this is a resistor, this is R value, and here resistor and the reactance value, that is inductive reactance. It is a capacitive reactance, it is an inductive reactance. It is nothing but a RL load. So this is a RL load, and this is a resistor, and this is a supply. And how to find out? What is the question? In the circuit shown, 3 voltmeter readings are given. So where the voltmeters are connected, first voltmeter V1 is connected across the source, V2 is connected across the resistor, and the voltmeter V3 is connected across the RL load. So they are given the values of V1, V2 and also the V3 values. Okay, next what is the question? They are asking the power factor of the load. They are asking about the power factor. Since it is a RL load, surely it will be a lagging power factor, and we have to see the magnitude. How to find out the magnitude of this? Because I know the voltage across this, I know the voltage across this, I know the voltage given by the source. How to find out this power factor? Which formula I have to use? Let us think and say. In this is a total voltage applied. V1 will be supplied to V2 and also V3. This is only the RT component. These two are passive components. It only supply the energy to the passive components. Okay. So your V1 is equal to V2 plus V3, but it is not a direct addition. What you have to do? We have to do it vectorially. Why we have to go for vectorial addition? Because it is a pure resistor. Here they are given. Here they are given a RL loader, resistor, and also it consists of a inductor. So it is a RL loader. So we cannot add it directly. So we have to go for vectorial addition. Which law we have to use? 2 laws I told. Triangular law of addition and parallelogram law of addition. So in this case, this is where V2 means V3 will be like this. So how to add it? We have to use the parallelogram law of addition. That is, this is V2 and this is where V3, draw a parallelogram. So we have to form the V2 and this is our V3, draw a parallelogram and find out the resultant vector. That resultant vector is your V1. So we know the V1 value, V2 value, V3 value. Then where the cos phi comes here, power factor, because if whenever we are taking this V2 and V3, there will be a phase shift. So that angle is phi, that is what? Cos phi. So V1 square is equal to V2 square plus V3 square plus 2 times of V2, V3 and then the cos phi. We know all the values V1, V2, V3. Substitute the values 220, 122, 136. All this in this equation and find out the cos phi value. We are getting 0.4526 is the power factor. Next question, 2006 gate question. An energy meter is connected to an immersion heater operating on an AC voltage source. They are given 230 volts, 50 Hz AC single phase source and it reads 2.3 kilowatt hour in 1 hour. What they are doing in the first sentence? They are taking the energy meter. That energy meter is connected to a water heater. Just for heater only. And that heater functions on 230 volts, 50 volts AC supply. And the energy meter reading is 2.3 kilowatt hour in 1 hour. So what is the energy? Integral PDT is nothing but the energy. So that is with respect to time, what is the power? That is the energy. So 2.3 kilowatt hour in 1 hour means what we have to do? If you are dividing it by the hour, we will get in terms of kilowatts. So we know that the power is equal to V square by R or V square by Z we can use. So here V square divided by R because it is a heater coil. So it is V square by R. So we can find out the R value. Next thing, the heater is removed from the supply. Now the heater is removed from the supply and now connected to 400 volt peak to peak value, square wave source. Previously it is a sine wave, now it is a square wave. And the frequency previously it is 50 Hz, now it is 150 Hz. What they are asking, the power in kilowatt dissipated by the heater will be. What is the power dissipated? How to find out? From the source one. That is, if it is connected with the AC source, find out the R value and substitute in the second question. That is second part. If it is connected in the square wave source, substitute the R value here and the answer will be 1.7391 in kilowatts. Next, see this one. Calculate the average power, apparent power and power factor for the figure shown. So this is a figure they are given. This is a AC source, 60 angle 0 volts. So what is a 60 angle 0 means? We can represent the complex number in case of 3 plus J4. This is called as rectangular form, or otherwise we can convert it into polar form. What is a polar form? We have to find out the magnitude and then the angle. How to find out the magnitude? Square root of 3 square plus 4 square. This is the magnitude. And how to find out the angle? Tan inverse of B by A. So that is the angle. So we can represent the complex number in terms of rectangular form or polar form. So we can easily convert. So here they are given in terms of polar form, 60 angle 0 volt. This is a AC source. Whenever they are putting sign like this, it is a AC source. And they are given two impedances, 2 minus J1, 1 plus J5 in ohms. They are given two impedances. Now take the question. Calculate the average power. They are asking the average power and the next they are asking the apparent power and they are asking the power factor. How to find out the average power, apparent power and power factor? Hint I have given here. This is a source. Current delivered by the source is IS. So I is equal to, according to Ohm's law, V by Z. So we know the V by Z value. V value is 60 angle 0 and we know the Z value. How to, which Z I have to take? I have to take Z equivalent always. So it is 2 minus J1 plus 1 plus J5. I have to find out the magnitude and I converted already in the polar form. The value is 12 angle minus 53.13. That is the I value. This part is magnitude. This is the angle. And the next one is apparent power. So what is the apparent power? How to find out the apparent power? Just V into I. I know the V value, I know the I value. If you are multiplying it, I will get, we are getting 720 VA. Unit of apparent power is volt ampere. So it is VA. Next one is average power. So average power is VA cos of theta minus phi. What is this angle theta? The angle of the voltage source. What is phi? Angle of the current. Because if you are representing the voltage, it may be VA sin omega t or it may be Vm sin of omega t plus theta, whatever may be the case they will give. And also they may give in terms of rectangular form or polar form. In this case already I find out the current in polar form. So already because it is given in the polar form. Sometimes they may give 30 degrees and that. At that case we have to supply. In this case it is 0. So your theta value is 0. And substitute the phi value. Phi value is minus 53.13. So substitute the value. And I am getting the average power as 432 watts. Next one is power factor. What is power factor? Cosine of the phase angle between the voltage and current. That is cos of theta minus phi. Because theta is the angle of voltage, phi is the angle of current. So substitute the values. I am getting the power factor as 0.6. And here they are given it is a lagging in nature. Next question. The same question we have taken, but in the difference is for the circuit shown in figure, determine the power factor of the combined loads. And the Z value is given as 10 ohms. Here it is 10 ohms. Previously it is 1 plus J5, now it is 10 ohms. So they are asking the power factor only. So we know the power factor formula. Just take the Z value, find out the current value, and they are given the voltage value, find out the phi. And we can find out the cos phi from that equation. The power factor it is coming around 0.9966, nearly unity power factor. So the power factor may be unity power factor, lagging power factor or leading power factor. Unity power factor means we will put UPF. Lagging or leading power factor means we will use LPF. So it may be LPF leading or LPF lagging. Beyond that we are having 0 power factor lagging and leading also. Thank you for watching this. problem. If you are having any doubts, you can come send the comments. We will see it in the next class. Thank you.